Hello and welcome everyone to our latest lecture on the proposed NOMA with dual transmission in multi-cell network. In this lecture, I will be discussing about the Matlab simulation code, the Matlab simulation code of the proposed algorithm and how we implemented it on Matlab. So I will quickly go through the code. The code is also available at www.researcherstore.com and the simulation section. And in the previous section, I explained the mathematical model and the mathematical equations behind the behind this dual multi-cell dual transmission system. So starting with the parameters that we have quickly assigned for the simulation, here are the parameters that we have assigned. These are the this this is a general format of code that you will see in OFDM system communication system, where we have assigned power to the user 1, user 2, Eve. Then we have designed the channel between user 1 and antenna 1, user 2 and antenna 1. Then there is a channel between user 1 and antenna 2, user 2 and antenna 2, and we design the channel as follows. Similarly, for the eavesdropper, we design the channel. Similarly, not for the eavesdropper, sorry, for the antenna 3 and the user 1, antenna 3 and the user 2. This is the for the base station 2 for antenna 4 and user 1 and antenna 4 and user 2. So these are the channel between the users and the antennas. Mm, Similarly, then X here is the transmitted data bits. X1 and X2 are the transmitted data bits of user 1 and user 2 that are first modulated, and then superimposed with the precoded matrices. The precoder matrices equations as designed in the previous lecture are that now written on MATLAB in the matrix form as follows, where we have for the 0 to we considered the value of m3 and m3b from 0 to infinity. So we consider a value randomly such as 2 and minus 2 for m3 and m3b, and m4a and m4b we consider 2 and minus 2. This can be any value from 0 to infinity, and this is the new degree of freedom that we have achieved in the multi-cell system. So it can give rise to several open research in this domain. Then we write the equations for the transmitted signal from antenna 1, antenna 2, antenna 3, and antenna 4 with superimposed precoder matrices as follows. Then we insert the guard interval, and here is the final received signal at user 1 from antenna 1. We do the convolution, add noise, do the FFT, then the final received signal at user 1 from antenna 1 is written as follows. Similarly, for antenna 2, antenna 3, and antenna 4, and all the received signals at reserve 1 from antenna 1, 2, 3, and 4 are then added, and it can be written as follows. Similarly, we can do it for user 2. I have not added the equations here. This is a precise code. This is not the actual code that we have used for the simulation. So you can consider writing the same kind of code for user 2 also. I have not added the equations here. Then we do the demodulation of the receive signal. Here we have considered only the code is missing for user 2 actually. So it will be the same as user 1. So we did the demodulation of user 1 signal, and then use the bit error rate formula this for the calculation of bit error rate, throughput, and peak to average power ratio. So I hope you understand. The basic idea of this lecture is to make you understand the code. I hope you have understood this code very well. And if you have any questions, you can email me for one-to-one session. So, and I will explain you this code myself, and I will give you my own consultation for your coding and for your research ideas. So I hope you find this lesson beneficial for you. Hope to see you in the next lecture.